Okay, so we have a third free body diagram here. So we're going to draw and solve. So first of all, it says a rightward force of 7 newtons is applied to a 2.5 kilogram book in order to move it steadily across the desk. Consider frictional forces. What would the coefficient of friction be? So let's start with our box. We'll put it on a level surface. We know that we have a rightward force or an applied force of 7 newtons. And then I'm going to have the force of gravity pulling down on that. And I'll assume you've watched the 2 previous videos going through how we determine those quickly. But if it's 2.5 kilograms, that's going to be a force of 25 newtons. And I'll sort of retrofit those with the applied force equals and the force of gravity equals 25 newtons. Okay. So now what do we do? Well, I know that my box is not falling. So it's got to be supported. So we're going to have the normal force here. And because I want to keep it the same, I'm going to write through my letters up to the top here. Maybe I should have thought about that and make this smaller, but these are not necessarily going to be to scale, but we're going to do the best that we can. So now it's not accelerating up or down, and it's moving steadily. That's a clue to us that this thing is moving at a constant velocity. And if the constant velocity is the case, then all our forces are in balance. So we're going to have a force of friction of 7 newtons as well. So this thing can move constantly with no acceleration. And then we're supposed to figure out what the coefficient of friction would be. Well, if it's moving steadily and the forces are balanced, we know that the applied force is 7 and the force of friction is 7 newtons.